Good morning, all of you. Good morning, students. Good morning, all of you. Good morning, students. Good morning. Join fast. We had just 45 minutes of time. Today we are going to discuss Fourier series concepts. Hurry up, students. Join fast. Nobody has joined till now. Join fast. Okay, let me start with my introduction. Myself, Venkata Krishna. My qualification is MTech Computer Science from IIT Kharagpur. I cracked GATE examination with All India rank 22. I had more than 15 years of teaching experience, particularly in GATE, in training the students in 3 different subjects. One is design and analysis of algorithms. That is the core subject for CSE students. Engineering mathematics for all branches and discrete mathematics again for computer science students. Now welcome to Unacademy. Unacademy is the best online platform in India for all competitive examinations. Why it is best? Let us see in terms of all of its features and subscription and cost. Basically, if you go to Unacademy, you can find 2 types of subscriptions. One is Unacademy Plus. You can find plus symbol here. Another one is Unacademy Iconic. You can find with the star symbol. Now let's talk about the available features in case of Unacademy Plus. In Plus, you will be having 4 features. One feature is live classes. You had already an experience of having this. Very important feature, live classes. Students can interact with faculty members directly through live. So another feature is a test series. Schedule will be in a proper structured manner. Another important feature is unlimited practice. What do you mean by unlimited practice? So you can find DPP in apps, daily practicing problems. Every day faculty will post questions on the name DPP, daily practicing problems. So it gives a lot of confidence among the students to clear any competitive examination. So whether it is a YouTube class or Unacademy free special class or class in Plus, faculty will discuss many questions. Okay, even if you want more questions, you can go through app. You can find DPP, daily practicing problems. So faculty will post questions. After some time, they will share the detailed solutions of DPP also. Next, let us talk about Unacademy Iconic. In case of Iconic, you will be having 4 features. One feature is personal coach. One coach will be appointed to you personally. Study planner will be there. You will be having guidelines from experts of subjects. You will be having questions and answers of engineering service examination mains, ESE mains. Now let us talk about the duration of subscription in Unacademy Plus and the cost. In case of Unacademy Plus, you can find 1 month subscription, 3 months of subscription, 6 months, 12 months, 18 months, and 24 months. So you can find these type of subscriptions. But let's talk about 12 months subscription, 18 months subscription, and 24 months subscription. Now in case of 1 year subscription, after using my referral code, this is my referral code. Dear students, remember this, GVK10 is my referral code. If you use my referral code, you will get 10% discount. So after discount, the fee structure will be 27,225 rupees per 1 year. If you unable to bear this amount at a time, you can go for EMI options also. So you can have 2,269 rupees per month. If you pay this 12 months continuously, you will get subscription. Whole syllabus will be covered with extraordinary previous year problems, so that it gives the confidence among students. Now, in case of 18 months, this was introduced very recently. So after using my referral code GVK10, the fee structure will be 34,650 rupees. Even you have EMI facility, this is 1925 rupees. In case of 24 months, after using my referral code GVK10, the fee structure will be 39,600. Even you have EMI facility, this is just 1650 rupees per month. Now let us talk about duration of subscription and cost in case of Unacademy Iconic. Here you can find only two types of subscription. So one is 12 months, another one is 24 months. 1 year, 2 year subscription. After using my referral code GVK10, the fee structure will be 45,225 rupees. You have EMI option, this is 3,769 rupees. In case of 24 month subscription, after using my referral code, the fee structure will be 66,600 rupees. So in case of EMI, it is just 2,775 rupees. Right. Now let us discuss 3 or 4 questions on Laplace transforms previous year. After that, we will go for Fourier series concept. Okay. What question, Bhargav, you are asking? Sir, is this series for free on YouTube? Which one? I did not understand your question. Okay, I can discuss later. So let me go through previous year questions. Now we have only 3 or 4 questions which are left from yesterday's. This was given to electronics students in 2015. Here f of t is defined like this. Between a and b. So when t is between a and b, the function is one constant. Outside these limits, it is 0. They were asking its Laplace transform. So let us apply the definition of Laplace transform at first. What is the definition of Laplace transform of f of t? This is integral 0 to infinity e power minus st into small f of t dt. But here the function is defined only between a to b. Outside the limits, it is 0. So instead of taking the limits 0 to infinity, let's take the limits from a to b. So this will be integral a to b e power minus st into f of t dt. So therefore, capital F of s. Capital F of s stands for Laplace transform. This is integral a to b e power minus st. Between a to b, the function is 1. Now apply the integration e power minus st integration. So this is e power minus st divided by minus s. Apply the limits. So here it is minus 1 by s is constant. So replace t by upper limit. This is e power minus bs minus e power minus as. So this is 1 by s into e power minus as minus e power minus bs. So its Laplace transform is 1 by s into e power minus as minus e power minus bs. So this is option C. C is my right answer. Got it? Because the function is non-zero between the limits a and b. Outside, below a, above b, it is 0. So instead of taking the limits from 0 to infinity, you can take limits from a to b. It becomes normal integral. Apply the limits, you will get option C. Okay. Good morning, Vasu. Good morning, Joseph. Chirag, what's your doubt? Sir, every lecture will be in English, right? Not Telugu. So you are expecting both in English or Telugu, or you are expecting only in English? I did not understand. Okay, ask me. Are you expecting every lecture completely in English or mixture of English and Telugu? This is as it is a Telugu channel. So I am supposed to use both Telugu and English. Okay, but in most of the cases, in 70% cases, not 70, in 80% cases, I am using English. Okay, suppose if you don't know Telugu, still you can attend my classes. You can understand each and every point. No issues at all. Okay, right, no issues. Don't worry. Next, question number 28. This was given to chemical students in the year 2014. Here f of t is given as t square. Then which of the following is a Laplace transform of integral 0 to t f of t dt? So we have a predefined formula to get the Laplace transform of integral 0 to t f of t dt. So here you can look at this Laplace transform of integral 0 to t f of t dt. We have a formula. This is 1 by s into capital F of s. What capital F of s denotes? Laplace transform of small f of t. So here small f of t is given as t square. So this is in the form of t power n. So it's Laplace transform capital F of s. Here what is my n value? N is a positive integer. If n is a fractional value, then use gamma function. If n is a positive integer, use factorial. So this is 2 factorial divided by s power 2 plus 1. Now this becomes 2 divided by s cube. So therefore in this case my answer is going to be 1 by s into 2 by s cube. So this is 2 divided by s power 4. We have, this is a direct formula. Laplace transform of integral 0 to t small f of t dt is 1 by s into capital F of s. What capital F of s denotes? Laplace transform of small f of t. So that is 2 by s cube. Multiply with 1 by s, you will get 2 by s power 4. So option D is right answer. Next, question number 29. This was given to chemical students in the year 2017. Chemical 2017. So Laplace transform of small f of t is given. What it is? Capital F of s. So this is s plus 1 divided by s into s plus 2. They were asking initial and final values of small f of t. They are asking initial value and as well as final value. So initial value, I value stands for initial value. That is basically f of 0. So in terms of small t, this will be limit t tends to 0 small f of t. But small f of t is not given. So therefore use the second version. As t tends to 0, s tends to infinity. Because time variable and signal variables are inversely proportional. So limit s tends to infinity, s into capital F of s. Students, are you following? So therefore this is limit s tends to infinity, s into capital F of s. This is I value. I value means initial value. So this is limit s tends to infinity, s into what is f of s? S plus 1 whole divided by s into s plus 2. So this s and this s gets cancelled. So therefore this is limit s tends to infinity, s plus 1 by s plus 2. So here we need to apply s tends to infinity. The numerator, in the numerator, the highest power of s is 1. Here also the highest power of s is n. You can take s common so that s reaches to denominator, so that 1 by infinity becomes 0. My evaluation will be very simple. So limit s tends to infinity, 1 plus 1 by s whole divided by 1 plus 2 by s. Now replace s by infinity, you will get 1. So here initial value is 1. So what is my initial value? It is 1. Right. Next, final value. So final value, this is limit t tends to infinity, small f of t. But small f of t is not given. So therefore here limit s tends to 0, s into f of s. So this is limit s tends to 0, s into f of s means s plus 1 by s into s plus 2. This is s plus 1 divided by s into s plus 2. So this s gets cancelled, replace s by 0, you will get 1 by 2. So initial value is 1, and final value is 1 by 2. So 1 and 1 by 2. Option B is right answer. B is my right answer. Next question. Yes, after completion of this question, I am going to start Fourier series. I am going to start within few minutes. Right. The Laplace transform of e power minus t into cos hyperbolic ht. This was given to Aerospace 2017. Here I did not provide options. It is not required. So let us evaluate directly. This is in the form L of e power at into f of t. L of e power at into f of t. By shifting property, this becomes what? Capital F of s minus a. What is capital F of s? Capital F of s is a Laplace transform of small f of t. So here cos hyperbolic phi t is given. Here cos hyperbolic phi t is given. So therefore let us find so in order to get the Laplace transform of e power minus t into cos hyperbolic phi t, first of all let us try to find the Laplace of cos hyperbolic phi t. Once you get Laplace transform of cos h phi t, you can shift s by s plus 1. Okay, because in this case a is becoming minus 1. Okay, now what is Laplace transform of cos hyperbolic at? This is s divided by s square minus a square. Here a value is 5. So Laplace transformation of cos hyperbolic phi t. This is s divided by s square minus phi square. This is s divided by s square minus 25. This is Laplace of cos hyperbolic phi t only. But I want Laplace transform of e power minus phi t into cos hyperbolic phi t. So here a value is minus 1. Now this is going to be f of s plus 1 according to this property because a is becoming minus 1. So here f of s is s by s square minus 25, but I need f of s plus 1. So replace s by s plus 1. This is s plus 1 whole divided by s plus 1 whole square minus 25. This is my final answer. Is it clear? So my final answer is s plus 1 whole divided by s plus 1 whole square minus 25. Right. Now with this we have finished Laplace transforms. Hope you had very good experience with Laplace transforms. Okay. Now let us talk about Fourier series. Right. So here we are going to discuss one particular series expansion of a function f of x. But don't think that for all functions we don't discuss series expansion. So first of all, let's talk about series expansion. Then we will discuss when a series expansion will be called as Fourier series expansion. Okay. So we have very specific functions. They are called periodic functions. So first of all, before discussing Fourier series, let me discuss a periodic function. Because for all functions, Fourier series may not be possible. Series means it has infinitely many terms. So in that case, for what type of functions Fourier series exists? So when you have a periodic function, so Fourier series, there is a chance of existence of Fourier series. So what do you mean by periodic function? Let us see. Suppose I am starting with a function f of x. So if a function takes same values after regular intervals of time, that will be called as a periodic function. A function which repeats the same value after regular intervals of time is called a periodic function. So this is English version definition of periodic function. What it is? A function which repeats the same value after regular intervals of time is called a periodic function. So first of all, let me write out this. After that, I will discuss mathematical version of periodic function by using some graphical examples. In that case, it will be very, very clear for all the students. So first, let me write out this, a function which repeats same value after regular intervals of time is called a periodic function. Is called a periodic function. Let me tell you one simple example, general example. So we always talk about days of a week: Monday, Tuesday, Wednesday, Thursday, Friday, like this. Now today is Friday. When I will get next Friday? After 7 days. So if my function aim is weekday, if f of x is weekday, when I will get Friday? Immediately after next Friday, after 7 days. So therefore currently we are in Friday. I will get Friday again after 7 days. For every 7 days, the same day will repeat. So if the function name is weekday, so it is a periodic function with a period 7. With a period 7. With a period 7. Even for every 14 days also it repeats. Even after every 21 days also same day will come. Even after every 28 days the same function, the same day will repeat. So out of all these numbers, 7 is the smallest number. Therefore, if I define weekday as a function, it is a periodic function with a period 7. I think now it is more clear. Generally, always we talk about sine function and cos function. That is very trivial example. Here also, today also, I am going to discuss sine and cos. Without discussing trigonometric functions sine and cos, we cannot discuss Fourier series of a periodic function. Okay, right. Now here let us see. That is a function f of x is said to be periodic if there exists a real number t such that f of small x plus t equal to f of x for all x belongs to domain of this function. In this case, the smallest value of t is called period of the function f of x. The smallest value of capital T is called period of f of x. In this case, you may start with 7. So 7 multiple is 14. If t is taken as 7, the same result is valid. The same, suppose if f of x plus t equal to f of x. Let me write out more clearly. So something is wrong. Let's verify once again. Suppose I have f of x plus t equal to f of x. Then this result also will work out. F of x plus 2t will be also equal to f of x. F of x plus 3t will be also equal to f of x. And so on. The same result is valid even for kt also. F of x plus kt is also equal to x. In this case, t is the smallest value. So such smallest value will be called as period of f of x. such a smallest function of f of x will be called as, such a smallest t is called period of f of x. No issues, right? Now let us take examples, general examples. Suppose I am talking with f of x equal to sin x. Here f of x plus 2 pi equal to sin of x plus 2 pi. Here you will get it as sin x. This is f of x. And 2 pi is the smallest number with the above property. Smallest number. Therefore, sin x is a periodic function with a period 2 pi. With a period 2 pi. The same case, cos x is also a periodic function with a period 2 pi. You can check it. Right. Let me take one more example. Suppose I am taking f of x equal to mod x. Absolute value. So mod x is nothing but plus or minus x. So generally we take y equal to f of x. So therefore y equal to mod x is a combination of two straight lines. So y equal to x and another one is y equal to minus x. Now let's draw the graph of this. Now here look at this. Suppose if I take this as minus 1, this is origin and this is 1. Suppose this is minus 2, this is plus 2. Now here you can look at this, draw the vertical lines here. So draw the vertical lines. Now here you can see the length is 2. Here the length is 4. That is clear. So here the function takes the same value. Here also the function takes the same value. So here what will be 2 or t, smallest value of t is 2. So t value 2, it is working 4, 6, 8, etc. So in this case 2 is the smallest number where the function repeats the same value. It means that I can directly write like this. F of x plus 2 equal to f of x for all x belongs to domain of mod x. It means that mod x is a periodic function mod x is a periodic function with a period 2. I think this point is clear. Mod x is a periodic function with a period 2. You can understand these points. Here this tick, this and this, the function takes same value. Here the length is becoming plus 2. Here also the function takes the same values. So in that case the length is becoming 4. That means the value of t is becoming 2. F of x plus 2 equal to f of x. This is a mathematical version. After every 2 units of time, the function takes the same value. After every 2 units, I should not say time. After every 2 units, the function takes the same value. So therefore, the possible values of t are 2, 6, 2, 4, 6, 8, etc. And out of this is the smallest number. So therefore, I can say that mod x is a periodic function with a period 2. Joseph, what's your doubt? Repeat mod x graph, sir. Very simple. Look at this. This is y equal to plus x, this line. This is y equal to x. This is y equal to minus x. Mod x is nothing but plus or minus x. So what is f of x value? Y value. So y equal to mod x is a combination of two straight lines. Y equal to mod x, y equal to plus x, another is y equal to minus x. It is just like V shape. Both lines will intersect at origin. Okay. Now we will discuss Fourier series definition. Right, very, very important definition. All of your attention, please. Suppose f of x is a periodic function. Let f of x be a periodic function defined in closed interval minus pi comma plus pi with a period 2 pi. So here first of all I am talking with the interval closed interval minus pi comma plus pi. So the length of this interval becomes pi minus of minus pi. This is going to be 2 pi. So what is my periodic function? F of x is a periodic function which is defined in closed interval minus pi comma plus pi. Ultimately its period becomes length of the interval. Length of the interval is upper limit minus lower limit, period 2 pi. Then f of x can be represented as follows. How to represent this? This f of x we can represent it as a naught by 2 plus summation n equal to 1 to infinity an cos nx plus bn sin nx. Now this is called, I can call it as equation 1. This equation 1 is called Fourier series expansion of f of x. This is called as Fourier series expansion of f of x. Now let us see what is a naught, what is an, what is bn. See here f of x has been represented as a linear combination of both sine and cos. Why they are so specific functions? You know the graph of sine x. So it is a wave shape. You know the graph of cos x, wave shape. Both are periodic functions with a period 2 pi. So once you know the properties of sine and cos, if you know that there is some another function which is also having same period 2 pi, then automatically I can represent f of x as a linear combination of both sine and cos, because I know the properties of sine and cos. Sine is a trigonometric function with a period 2 pi. Cos is a periodic function with a period 2 pi. There is some another function f of x which is also having period that is equal to 2 pi. So therefore, in order to get the properties of f of x, if f of x can be expressed as a linear combination of sine and cos, then my job becomes very simple. Even tomorrow I will tell you the important real applications of Fourier series also. Okay, I think this point is clear. So therefore, here what is my interval? This is closed interval minus pi comma plus pi. In the examination, sometimes they may give the domain of the interval as 0 to 2 pi. In that case, this is also a periodic function with a period 2 pi. Sometimes they may define the domain as closed interval minus L comma plus L. In that case, the length of this interval is 2L. Sometimes they may define a periodic function over closed interval a comma b. In that case, its period is 2L. but 2L is nothing but length of this interval, that is b minus a. So therefore, whenever f of x is a periodic function having period 2 pi, which is defined in closed interval minus pi comma plus pi, then f of x can be represented like this linear combination of sine and cos. Here a naught is called a Fourier coefficient, an is a Fourier coefficient, bn is a Fourier coefficient. Now let us see what are the various different expressions, various formulae to define a naught, an, bn. They are very important for examination point of view. Now look at this. Where a naught, comma an, comma bn are called Fourier coefficients and they are given by as follows. They are given by as follows. So first of all, let me write out what is a naught. A naught is 1 by pi into integral minus pi to plus pi, because the domain of the interval is minus pi to plus pi. F of x dx. What is an? 1 by pi into integral minus pi to plus pi f of x into cos nx dx. What is bn? Bn is 1 by pi into integral minus pi to plus pi f of x into sine nx dx. So these are various formulae to get a naught, an, bn. In the examination, sometimes they may ask you directly what is a naught. Sometimes they may ask you an. Sometimes they may ask you bn. Sometimes they may give like this. The Fourier series expansion of this particular function f of x defined in closed interval minus pi comma pi is given below. Then using this Fourier series expansion, what is the sum of infinite series? So one of the important applications of Fourier series is finding sum of infinite series. Tomorrow we will solve some problems. Okay. Are you following, students? So a naught equal to this, an equal to this, and bn equal to this. The points are clear. A naught is Fourier coefficient, an is Fourier coefficient, bn is Fourier coefficient. For all the expressions, 1 by pi is common. Integral is common, minus pi to plus pi. F of x is part of a naught, an, bn. So here f of x, in case of an, take f of x along with cos nx. In case of bn, take f of x along with sin nx. So these are very important. Now let me write out some formulae. Some useful formulae. Sin n pi is 0. Cos n pi, this is minus 1 whole power n. Sin 2n pi is 0. If sin n pi is 0, sin 2n pi becomes 0. Trivial thing. Cos 2n pi, this is always 1. So here n value is an integer. N is always an integer. That is very clear. Okay. Now let us take one simple example. Okay. Suppose f of x is defined like this. It is a split function. It is minus 2 if minus pi less than x less than 0. 2 if 0 less than x less than pi. Now you can see the function is defined in closed interval minus pi comma plus pi. So its period is 2 pi. But from minus pi to 0 it is minus 2. From 0 to pi it is 2. Now let us try to find a naught, an and bn. So here a naught is 1 by pi into integral minus 1 by minus pi to plus pi f of x dx. So it is 1 by pi into, split the integration, because function is defined from minus pi to 0, 0 to pi. Minus pi to 0, f of x dx, 0 to pi, it is f of x dx. So this is 1 by pi into integral minus pi to 0. From minus pi to 0, what is my function? Minus 2. 0 to pi, it is 2. So therefore this is minus 2 dx plus 0 to pi, this is 2 dx. So therefore this is 1 by pi into, this is minus 2. Limits are, integrate dx is x minus pi to 0 plus 2 into integral dx is again x 0 to pi. So therefore this is 1 by pi into minus 2. This is plus pi. This minus 2 pi. This is plus 2 pi. Now its value is becoming 0. Now let me calculate an. Here an formula is 1 by pi into integral minus pi to plus pi f of x into cos nx dx. Let us apply the same structure. This is 1 by pi into, so again split the integration from minus pi to 0, f of x into cos nx dx plus 0 to pi f of x into cos nx dx. So therefore this is 1 by pi into, from minus pi to 0 it is minus 2. So I am writing minus 2 here. Minus 2 into integral minus pi to 0 cos nx dx plus 2 into integral 0 to pi sin nx dx. Sorry, this is cos nx. Let me correct this. This is cos nx. So in this case, my an is becoming 1 by pi into minus 2 into, what is integral cos nx sin nx by n. Limits are from minus pi to 0. Plus 2 into, again the integral of cos nx is sin nx by n. Limits are from 0 to pi. So therefore this is 1 by pi into minus 2 by n into sin 0 0 minus sin of minus n pi plus 2 by n into sin n pi minus sin 0. Sin minus n pi is minus of sin n pi, that becomes 0. So sin n pi also 0. So it is becoming 1 by pi into minus 2 by n into 0 minus 0 plus 2 by n into 0 minus 0. So here also my expression for an is becoming 0. My expression for an is becoming 0. So I will calculate bn tomorrow. Let me take one more example tomorrow. And tomorrow I will discuss Fourier series of even function, Fourier series of odd function. Even let us see the major application of Fourier series. In what way Fourier series is going to help us? Here I wrote this one. This is the Fourier series expansion of f of x. So if you represent f of x like this, what are the advantages? Tomorrow we will see by taking different examples. Tomorrow we will talk about Fourier series of even function, odd function, and let us try to find sum of infinite series using this Fourier series expansion. Okay. This is official Creatrix channel where you can find more than 10,000 members. This is our Telegram channel where you can get links of our live classes and notes in PDF format. As soon as the class gets completed, We faculty members are sharing notes in PDF format. These are India's #1 study channels running by Unacademy. Right. Thanks a lot, guys. Today, one important announcement from 11 p.m. So not 11 p.m. It is from 12 p.m. to 1 p.m. We have a special class on differential equations. I'm going to discuss particular integrals of various complicated differential equations from 12 p.m. to 1 p.m. Within 2 hours, I'm going to take a special class in Unacademy, free special class. So join with me, students. You can get a lot of fun. Okay. And today evening, as usual, from 7 p.m. to 8:30 p.m. we have a regular class that is on vector space. Okay.